long before the drills, the broken rock, and the pale dust of a barite mine, a low limestone ridge rises above western Morocco. The air is cooler than it is today. The horizon is not sealed by dunes. Open grasslands stretch between patches of scrub. Seasonal water gathers in shallow channels and temporary pools. Gazelles move across the plain in restless groups, while larger hoofed animals follow routes shaped by rain, pasture, and memory. In the limestone, a shallow cast shelter opens toward this changing country. Not a vast underground labyrinth, but a protected edge between stone and open ground. Around 315,000 years ago, that modest refuge becomes part of a human world. The place now called Jebel Irhoud lies in the province of Yusufia, about 100 kilometers west of Marrakesh and 50 southeast of Safi. Today, its surroundings can appear dry, exposed, and austere. It is easy to project that barrenness backward and imagine a harsh Sahara. Yet the animal remains preserved at the sight point toward a more complicated setting. Rodents, gazelles, and other mammals suggest open country, but not the same severe aridity visible later. The ancient landscape shifts with climate. Water becomes more reliable, then less so. Corridors open across North Africa, and later close again. Human populations living within this unstable geography do not inhabit a fixed world. They inhabit a continent that repeatedly rearranges the possibilities of movement. This changing mosaic of grass, scrub, exposed stone, and temporary water would shape where animals gathered, where hunters watched, and when journeys became possible again. Before we go deeper, take a moment to like the video and subscribe, if this is the kind of history and mystery you enjoy. The story is not simply about an old skull or a date pushed backward. It is about how a familiar kind of face appears in an unfamiliar phase of human evolution, in a region once treated as peripheral to the origin of our species. The limestone shelter at Jebel Irhoud occupies a useful position. It offers shade, protection from wind, and a view across open terrain. It is close enough to productive hunting grounds to attract repeated human activity, yet the surviving evidence does not tell us whether people live there continuously, return seasonally, or use it only briefly. What survives in the record suggests organized visits, stone tools, fire-heated flint, animal bones marked by cutting and breakage, and scattered human remains. But the duration and rhythm of those visits remain uncertain. The shelter may have been a camp, a working place, a stopping point, or each at different times. No single explanation fully accounts for every layer of activity. Its importance comes partly from geography. For much of the 20th century, popular accounts of human origins favoured a simple map. Modern humans emerged in one restricted part of East Africa and later spread outward. That picture was more orderly than the fossil record deserved. Jebel Irhoud disturbed that neat arrangement. Here, in the far northwest of Africa, human fossils associated with Middle Stone Age technology appeared earlier than expected. Their age and anatomy implied that the early history of Homo sapiens could not be confined so easily to one corner of the continent. This does not make Morocco the single birthplace of humanity. It does not prove that the individuals who used this shelter were the direct ancestors of everyone alive today. It does not erase East Africa, South Africa, or other regions from the story. Instead, Jebel Irhoud widens the stage. It suggests that populations carrying different parts of the anatomical pattern, later recognized as Homo sapiens, were already distributed across large areas of Africa. Some groups may have been separated for long periods by dry zones, mountains, distance, or ecological change. At other times, wetter climates could have reopened roots, allowing people, genes, and technologies to move between regions. Scholars still debate how often these populations met and how much each contributed to later humans. But the older image of one isolated cradle has become increasingly difficult to defend. The Sahara itself is central to this uncertainty. It is often imagined as a permanent wall between northern Africa and the rest of the continent. During the Pleistocene, however, that wall could become porous. Rainfall patterns shifted. Lakes formed where none exist today. Rivers crossed regions that later dried. Grasslands spread northward, carrying animals and perhaps human groups with them. Then conditions reversed, and populations could become isolated again. This alternation between connection and separation offers one possible framework for understanding why early Homo sapiens features appear in different African regions without looking identical everywhere. At Jebel Irhoud, the people themselves are known only in fragments, parts of skulls, jaws, teeth, and a limited number of bones survive, representing at least 5 individuals. Their remains do not provide complete bodies or perfect portraits. No ancient DNA has been recovered, so their skin color, hair, eye color, close kinship, and relationship to any living population cannot be directly known. Even the famous faces are reconstructed from incomplete and sometimes distorted bone. The evidence is powerful, but it is not a photograph. What makes these fragments extraordinary is their combination. The front of the skull can look unexpectedly close to the human condition seen today. The face is relatively short and positioned beneath the brain case rather than projecting strongly forward in the Neanderthal manner. Yet behind that face, the skull remains long and low. The brain was large, but the internal shape had not yet become the rounded, globular form characteristic of later Homo sapiens. The contrast is subtle and profound. It suggests that the anatomy of our species did not arrive all at once. Different features changed at different rates, producing people who belonged within our evolutionary story without being exact copies of us. That is why this damaged shelter matters so much. It preserves not a clean beginning, but a transitional population in a transitional landscape. The open country beyond the cave changes with the climate. The routes across Africa expand and contract. Human groups become connected, then divided. Anatomy itself seems to follow the same uneven pattern, with modern-looking traits appearing beside older ones. The ridge at Jebel Irhoud therefore stands at 2 thresholds. One is geographical, between the Atlantic edge of North Africa and the vast interior of the continent. The other is biological, between earlier human forms and the emerging pattern of Homo sapiens. In both cases, the boundaries are blurred. The site offers no single moment when one species suddenly becomes another. Instead, it gives a brief view into a long process already underway. While the people who left their tools and bones beneath the limestone could not have known that their faces would one day force the human past to open wider, the threshold between landscape and human history remained hidden until the 20th century, when the limestone ridge was opened not by archaeologists but by miners. In 1961, workers extracting barite from Jebel Irhoud struck a fossilized human skull. It emerged from a place already disturbed by blasting, cutting, and the movement of sediment. The specimen later known as Irhoud I did not come with the careful measurements, photographs, coordinates, and layered records expected from a modern excavation. It arrived suddenly, separated from much of the context that would have explained it. That accident shaped everything that followed. A fossil can preserve anatomy, but archaeology depends on relationships: which layer held the bone, which tools lay beside it, which animal remains belonged to the same occupation, whether fire had altered the sediment, and whether later disturbance had shifted objects from their original positions. At Jebel Irhoud, mining had already removed large parts of the cast shelter. Material had been displaced. Portions of the original cave were gone. The surviving deposit no longer formed a complete archive. Irhoud I was scientifically important from the moment it appeared, yet it was also frustratingly detached from the precise circumstances of its burial. The circumstances were ordinary by the standards of industrial work and extraordinary by the standards of human origins. No excavation team had selected the spot after surveying the landscape. No grid had been laid across the floor. The skull entered science because commercial quarrying cut through a deposit that had survived for hundreds of millennia. Emile Iannucci published the early find, giving researchers their first formal description of a specimen whose importance could not yet be measured. Its laboratory name made it sound orderly, but Irhoud I carried the disorder of its discovery in every question asked about it. The skull itself invited comparison. It had a large brain case, pronounced brow ridges, and a long, low cranial form. To researchers working in the early 1960s, those features looked archaic. Europe provided the most familiar framework for interpreting ancient human fossils, and the stone tools associated with Jebel Irhoud were initially compared with the Mousterian, a technological label strongly linked at the time with Neanderthals. The combination seemed persuasive: an old-looking skull beside tools resembling those from European Neanderthal sites. Irhoud I was therefore described as a North African Neanderthal or, in some accounts, an African form of Neanderthal. The classification was understandable within the knowledge and habits of the period, but it rested on assumptions that would later prove misleading. Tool traditions do not map neatly onto biological species. Similar methods of preparing stone cores can appear among different populations, and archaeological labels created for Europe do not necessarily transfer cleanly to Africa. Morphology can also deceive when a fossil carries a mixture of ancestral and derived traits. Irhoud I did not fit comfortably into any simple category, but the categories available to researchers were broader and more rigid than the fossil record itself. Its age was equally uncertain. Without intact stratigraphic context and without a suitable dating method, the skull floated through a wide chronological range. Early estimates placed the remains tens of thousands of years in the past, sometimes around 40,000 years, sometimes far older. Radiocarbon dating could not solve the problem because the site was ultimately much too ancient for the method's effective range. At the time, however, no one knew just how far beyond that range the relevant deposits extended. The apparent Mousterian resemblance encouraged a comparatively late date. Reinforcing the Neanderthal interpretation in a circular way, the tools suggested Neanderthals. The skull looked archaic, and the presumed Neanderthal identity supported a younger chronology. More fossils appeared during excavations in the 1960s. Irhoud II added another skull. Irhoud III preserved a lower jaw from an immature individual. Irhoud IV was a humerus, and Irhoud V included part of a pelvis. Teeth and other fragments expanded the sample. Yet these discoveries did not fully repair the original loss of context. Some came from controlled excavation, but the site had already been heavily altered. The exact three-dimensional position of Irhoud I was not recorded, and the relationship between early finds, archaeological layers, and displaced sediment remained difficult to reconstruct. This is one of the less visible problems in paleoanthropology. A spectacular fossil can attract attention, but the missing centimeters of sediment around it may matter just as much as the bone. Context determines association. Without it, researchers must rely more heavily on anatomical comparison, geological inference, and the imperfect memories or records of those present during the discovery. The evidence remains incomplete, and every later interpretation has to carry that limitation forward. The mining damage also changed the physical appearance of Jebel Irhoud. What had once been a cast cavity or shallow rock shelter within limestone became an exposed and broken site. Modern images can make it seem as though ancient people lived in an open pit beneath a bare cliff. That is an illusion created by extraction. The Pleistocene occupants knew a more enclosed place, though probably not a deep cave. Much of that original setting had vanished before scientists could document it. As additional anatomical studies accumulated, the Neanderthal label weakened. The face did not show the same projecting mid-facial architecture characteristic of Neanderthals. The jaws and teeth aligned more closely with the Homo sapiens lineage. The skull still looked ancient, but its ancient appearance came largely from the elongated cranial vault, rather than from a truly Neanderthal face. Irhoud I had been placed in the wrong branch, partly because researchers expected an archaic skull to belong to a familiar archaic category. Even so, rejecting the first classification did not immediately reveal the correct answer. Some researchers viewed the fossils as an unusual regional population. Others considered them close to early modern humans but not fully within Homo sapiens. Species boundaries in the Middle Pleistocene remain difficult because evolution does not produce fossils according to tidy labels. Populations change over long intervals, and traits appear in combinations that later disappear. What survives at Jebel Irhoud captures one such combination. The first skull, therefore, became both evidence and obstacle. It demonstrated that an important human population had occupied western Morocco, but its damaged context prevented a secure chronology. It offered a face that seemed almost familiar, attached to a skull that did not. It drew attention to North Africa, yet the assumptions used to interpret it initially obscured its real significance. For decades, Irhoud I remained caught between its anatomy and its uncertain age. The mine had revealed the fossil, but the mine had also destroyed much of the information needed to understand it. Only by returning to the broken hillside and locating untouched deposits could researchers hope to connect human remains, tools, animals, fire, and time in the same archaeological frame. The attempt to recover that missing frame began with the fossils already in hand. Irhoud I was no longer alone. Each new fragment complicated the picture, not because it answered the central questions, but because it revealed that the site preserved a population rather than a single unusual individual. The second skull, Irhoud II, repeated enough of the same broad anatomy to show that the first find was not merely an anatomical exception. The long, low vault and robust brow region appeared again, while the face remained unlike the projecting midface of a classic Neanderthal. Similarity between the two skulls gave the assemblage coherence, but the differences also warned against turning one fossil into a portrait of the entire group. Irhoud III added a different kind of evidence. It was a lower jaw from an immature individual, preserving developing teeth that later allowed researchers to examine growth with remarkable precision. Microscopic lines in enamel and dentine recorded the rhythm of dental formation, almost like a biological calendar sealed inside the tooth. The individual was approximately 7.5 to 8 years old. That estimate does not reveal the circumstances of death, family relationships, or social position. and the record offers no secure basis for reconstructing such details. What it does provide is a glimpse of development. The pattern of dental growth appears closer to Homo sapiens than to more archaic humans, suggesting that aspects of the prolonged developmental schedule associated with our lineage had already begun to emerge. Other remains widened the anatomical sample beyond the head. Irhoud 4 preserved part of an upper arm bone. Irhoud 5 included a portion of the pelvis. Additional teeth and fragments came from the disturbed deposits and early excavations. Later work would recover more cranial pieces, jaws, vertebrae, ribs, and parts of the limbs. Taken together, the published collection is commonly described as around 22 human fossil specimens representing at least 5 individuals. That distinction is essential. 22 specimens do not mean 22 people. A tooth, a fragment of skull, and part of a femur may belong to one person or to different people. Nor do 5 individuals mean 5 complete skeletons. The remains are incomplete, separated, and unevenly preserved. The minimum count of 5 rests on anatomical duplication, age differences, and the combination of preserved elements. Researchers can sometimes tell that 2 bones cannot come from the same body because they repeat the same side or represent incompatible stages of development. Even then, the minimum number is conservative. There may have been more individuals, but the surviving sample cannot prove it. The assemblage includes adults, an immature individual, and a younger child. Yet it does not establish that they occupied the shelter at the same moment. Their bones could have accumulated across separate visits or over an extended period. Nothing securely identifies as a single catastrophe, a family group, or a collective burial. This uncertainty matters because human imagination naturally tries to reconnect scattered bones into a scene. 5 people in one shelter sounds like a group that can be pictured faces around a fire, hunters returning with gazelle, relatives sharing food. The archaeology does not justify that degree of certainty. The fossils are not arranged as a burial. There are no graves, grave goods, or ritual structures. The cause of their presence remains unresolved. Some remains may have entered the deposit through ordinary occupation processes, later disturbance, or geological movement. No single explanation fully accounts for the accumulation, and the mining damage makes the original pattern harder to recover. The famous skulls also resist being reduced to one standardized face. Irhoud 1 has often become the visual representative of the site, but Irhoud 2 and the later cranial remains do not match it in every detail. Brow ridges vary, bone thickness, proportions, preservation, and distortion differ. Some differences may reflect age or sex, while others may be normal individual variation. Geological pressure can alter shape after burial, and missing portions must sometimes be reconstructed. The population was not a row of identical figures. It was a small and fragmentary sample of people who varied, as human populations always do. One of the most informative later discoveries, Irhoud 10, demonstrates how much scientific work can stand between a fossil and the image presented to the public. The specimen consisted of crushed and distorted cranial fragments rather than an intact skull. Researchers used microcomputed tomography to separate pieces digitally, correct deformation, align surviving surfaces, and mirror missing anatomy where justified. The resulting reconstruction is grounded in real bone, but it is not simply a complete face lifted from the sediment. It combines preserved evidence with carefully controlled restoration. That distinction does not weaken the fossil. It clarifies what is observed and what is reconstructed. Irhoud 11, a large adult lower jaw recovered from an intact archaeological layer during the renewed excavations, added another crucial element. It lacked the fully developed projecting chin common in many recent humans, yet its overall morphology belonged more comfortably within the early Homo sapiens pattern than within a Neanderthal one. The jaw was robust, and its combination of features resisted simple labels. A modern chin is not the single gate through which a fossil must pass to enter our species. Classification depends on the total pattern of face, teeth, jaw, cranial vault, and internal brain case shape. The teeth were especially valuable because they survive well and carry both taxonomic and developmental information. Their size, root form, enamel structure, and wear can be compared across fossil populations. At Jebel Irhoud, the dental evidence repeatedly points toward the Homo sapiens lineage, even where the skull vault retains a more archaic shape. This anatomical mismatch became one of the site's defining clues. The people were not modern in every visible respect, but neither were they simply late representatives of an older form. Even small fragments could alter the emerging human family tree. As the collection grew, the question changed. Researchers were no longer asking what kind of individual Irhoud 1 might have been. They were asking what kind of population could combine relatively modern facial and dental anatomy with elongated, low brain cases, robust jaws, and variable brow ridges. The answer could not come from naming one skull. It required understanding variation across several individuals and separating shared evolutionary traits from differences caused by age, preservation, or ordinary diversity. Yet anatomy alone could not reveal when these people lived. A population could be identified as unusual, early, or transitional only in relation to time. Without a secure date, every comparison remained unstable. The fossils had multiplied, but the chronology still floated. For decades, the faces gathered at Jebel Irhoud remained suspended between tens of thousands and hundreds of thousands of years, waiting for a method capable of turning their surrounding fire and stone into a reliable clock. For years, the most misleading feature of Jebel Irhoud was not the shape of the skulls but the age assigned to them. The fossils looked ancient, yet the estimates often placed them astonishingly late, sometimes around 40,000 years ago and sometimes somewhere beyond 100,000. That uncertainty did more than blur the chronology. The absence of a secure date also encouraged every new comparison to pull the fossils toward whichever population happened to look most similar within the published collections then available internationally. The error persisted because each assumption quietly reinforced those surrounding it. It shaped the identity of the people themselves. A fossil believed to be relatively young could be compared with late Neanderthals, early modern humans, or regional survivors of older populations. The same skull, placed hundreds of thousands of years earlier, would demand a completely different evolutionary explanation. The first estimates were built from limited tools and damaged context. Radiocarbon dating could not reach far enough into the past, though researchers did not initially know just how far beyond its range the deposits extended. The original mining had removed sections of the shelter, shifted sediments, and separated Irhoud 1 from an exact recorded position. Some stone artifacts resembled prepared core industries known from Europe, so they were described as Mousterian. In the mid-20th century, that label carried a powerful implication. Mousterian technology was closely associated with Neanderthals, and the association encouraged researchers to read the Moroccan fossils through a European framework. The logic appeared straightforward. The skulls were long and low, their brow ridges were strong, their cranial vaults lacked the rounded form of recent Homo sapiens. the tools seemed Mousterian. Therefore, the people were probably Neanderthals or a North African population closely related to them. But each step in that chain contained uncertainty. Long, low skulls are not unique to Neanderthals. Robust brow ridges occur in several human populations. Stone technology can spread between groups or arise through similar solutions to similar practical problems. A technological label does not identify the anatomy of the person who made the tool. This mattered especially in Africa, where archaeological sequences developed under different environmental and population histories. Calling the Jebel Irhoud artifacts Mousterian imported a European name into a North African context, and then allowed the name to influence the biological classification of the fossils. Later researchers increasingly preferred to place the assemblage within the African Middle Stone Age, emphasizing Levallois prepared core methods, points, scrapers, and retouched flakes without assuming that their makers were Neanderthals. The change in terminology was not cosmetic. It removed a false certainty that had attached species identity to a toolkit. Anatomical reassessment weakened the Neanderthal interpretation from another direction. Neanderthal faces typically show a distinctive projection through the middle of the face, including the nasal region. The Jebel Irhoud faces do not share that pattern in the same way. Their facial structure is relatively short and positioned beneath the brain case, closer in broad organization to Homo sapiens. The jaws and teeth also carry features that fit more comfortably within the sapiens lineage. What looked Neanderthal-like was concentrated mainly in the robust brow region and elongated cranial vault, features that could represent an earlier stage in the evolution of our own branch rather than membership in the Neanderthal branch. Yet removing one label did not solve the date. Without a secure chronology, the fossils could still be interpreted as a late surviving archaic group or as early modern humans retaining primitive traits. Some estimates placed them around 40,000 years ago, an age that would have made their anatomy unusually archaic for such a late period. Others pushed them beyond 100,000 years, but the range remained broad. The evidence was not strong enough to decide whether Jebel Irhoud belonged near the end of an old lineage or near the beginning of a new one. A major effort to improve the chronology came through the tooth of Irhoud III. In 2007, researchers used a selectron spin resonance, combined with uranium series information, to estimate its age. The initial results suggested roughly 160,000 years. That was already far older than the most restrictive early estimates and weakened the idea of a very late North African Neanderthal-like survival. Even so, the value depended on reconstructing the radiation dose absorbed by the tooth over time, including the movement of uranium into dental tissues. Such calculations require models, and different assumptions can shift the result. When the radiation environment was later recalculated using improved information from the renewed excavation, the estimated age moved substantially older, to about 286,000 years with an uncertainty of 32,000 years. That revised result aligned much better with the age obtained from the intact archaeological layers. The change illustrates why scientific dates should not be treated as permanent numbers engraved into fossils. Dating is an argument built from measurements, environmental reconstruction, physical models, and uncertainty. When the context improves, the calculation can improve with it. The earlier mistake was therefore not a single careless guess. It was the product of an incomplete sight, limited dating methods, inherited terminology, and a human tendency to fit unfamiliar evidence into familiar categories. Researchers saw a robust, elongated skull beside tools labelled Mousterian, and placed it within the best-known archaic population of the period. What they lacked was a reliable clock and a wider African comparison. Once the fossils began moving deeper in time, their strange combination of features became more meaningful. A relatively modern face attached to an archaic-looking brain case no longer had to be explained as a late anomaly. It could represent a population living near the early diversification of Homo sapiens, when facial anatomy had changed more quickly than cranial globularity. The same morphology that seemed awkward at 40,000 years became evolutionarily revealing near 300,000. The revised chronology also changed the scale of the question. Jebel Irhoud was no longer simply a North African curiosity. It challenged the prevailing idea that recognizable Homo sapiens appeared only around 200,000 years ago, mainly in East Africa. If the Moroccan fossils truly belonged near 300,000 years, then the roots of our lineage were older, geographically broader, and anatomically less uniform than many accounts had assumed. Still, the decisive evidence could not come from the old fossils alone. Their original positions were too uncertain, and the mine had erased too much. What was needed was a surviving layer where human remains, tools, animal bones, traces of fire, and datable sediment remained connected. Only then could the site escape the circular logic that had trapped it for decades. The skulls had been called Neanderthal because they seemed young and archaic, and they seemed young partly because they had been called Neanderthal. To break that circle, researchers would have to return to the quarry, find the untouched remnants of the shelter, and let the geology establish the age before anatomy established the name. The return to Jebel Irhoud in 2004 began with a deceptively simple question. Had anything survived by then? Decades of mining had opened the limestone ridge, removed much of the original shelter, and left the site looking more like an exposed quarry than a place once used by people in the Middle Pleistocene. The old discoveries had demonstrated that important human fossils were present, but the relationships among bone, tools, animals, fire, and sediment remained uncertain. A new Moroccan-German project, led by Abdelouahed Ben Nser and Jean-Jacques Houblin, came back not merely to find more fossils, but to recover the context that the mine had destroyed. The first task was geological. The team had to identify surviving pockets of sediment still attached to the original walls and floor of the karst cavity. These remnants were limited, irregular, and partly hidden beneath debris. Excavators could not assume that every visible deposit was intact. They had to distinguish undisturbed archaeological layers from material shifted by quarrying, erosion, or earlier digging. That meant recording sediment color, texture, slope, contact surfaces, stone concentrations, and the exact position of each object. The work was slower than the first discovery and less dramatic to watch, but it addressed the central weakness of the entire site. An intact layer can transform a fossil assemblage. When a human bone is found securely within the same deposit as stone tools, butchered animal remains, and traces of heating, researchers can argue that those materials belong to the same broad archaeological context. They can date the layer, reconstruct activities, and evaluate whether objects were moved after burial. Without that association, a skull may still be anatomically informative, but its place in time and behavior remains unstable. At Jebel Irhoud, recovering such a layer would allow the site to move from a collection of intriguing fossils to a documented episode in early Homo sapiens history. The renewed excavations eventually located the crucial deposit known as Layer 7. Unlike the sediments disrupted by mining, this layer remained relatively coherent. It contained human fossils, Middle Stone Age artifacts, animal bones, and fire-heated flint in stratigraphic association. The discovery did not restore everything that had been lost, and it could not return Irhoud 1 to an exact coordinate. Yet it provided the secure archaeological frame that earlier researchers had lacked. Among the most important new finds were cranial fragments later assembled as Irhoud 10 and the robust lower jaw known as Irhoud 11. These remains came from controlled excavation, with their positions recorded in relation to the surrounding deposits. Other human fragments expanded the sample to around 22 published specimens, representing at least 5 individuals. Once again, the numbers required care. The excavators had not uncovered a chamber containing 5 complete bodies. They had found scattered parts of several people within an archaeological layer shaped by occupation, burial processes, time, and later geological pressure. Irhoud 10 was especially challenging. The skull fragments had been crushed and distorted in the sediment, so they did not emerge as a recognizable face. Microcomputed tomography allowed researchers to scan the pieces, separate them digitally, and correct some of the deformation. Fragments could be repositioned according to matching surfaces and anatomical landmarks, where one side was better preserved than the other. Careful mirroring could help restore missing geometry. The final reconstruction was therefore both a fossil and a technical achievement, real bone interpreted through a transparent digital process, rather than an untouched skull simply lifted from the ground. Irhoud 11 offered a different kind of clarity. As a mandible found within Layer 7, it directly linked human anatomy to the newly documented archaeological context. The jaw was large and robust, and it did not possess the fully projecting chin common among many recent humans. Even so, its total pattern fit the early Homo sapiens lineage more closely than it fit Neanderthals. This combination reinforced the idea that familiar human traits emerged unevenly. Faces, teeth, jaws, and brain cases were not changing in perfect synchrony. The new excavation also made daily activity more visible. Levallois cores and flakes showed planned stone reduction, in which a core was shaped in advance so that a flake of intended form could be struck from it. Points, scrapers, retouched pieces, and waste from tool production appeared in the assemblage. Some raw material had likely been transported from sources around 30 kilometers away, suggesting that the people who used the shelter moved through a landscape much larger than its immediate surroundings. The evidence does not show whether they collected the stone directly or obtained it through contact with others, but it reveals deliberate selection and movement. The excavators also treated absence as evidence. Small flakes were less common than might be expected from intensive tool manufacture, while retouched pieces were comparatively frequent. This pattern may indicate that many tools arrived already prepared, were maintained at the shelter, and left again with their users. It suggests planned mobility, although the exact duration and purpose of each visit remain debated. Animal bones added another layer. Gazelle dominated the preserved food remains, accompanied by other hoofed animals and occasional ostrich eggshell. Cut marks, impact damage, and fresh bone fractures indicate that humans processed carcasses, removed meat, and broke long bones to reach marrow. Yet the excavators could not reconstruct a complete menu. Plant foods rarely preserve as well as bone, so the prominence of gazelle in the archaeological record does not prove a diet composed only of meat. Fire was present as well, though not every heated stone need have been deliberately placed in a formal hearth. Some flints had been exposed to temperatures high enough to reset signals within their crystal structure. For the people at the shelter, the heating may have been accidental, practical, or connected to repeated use of fire in activity areas. For later researchers, those altered stones became the key to dating the deposit. The ordinary residue of ancient fire preserved a physical clock. The renewed excavation therefore recovered more than additional anatomy. It connected bodies to behavior and behavior to geology. The people of Jebel Irhoud were no longer represented only by skulls of uncertain age. They could now be placed beside prepared stone tools, transported raw materials, butchered gazelles, marrow extraction, and repeated fire use within a surviving layer of the shelter. Important limits remained. The site still did not reveal whether occupation was continuous or seasonal. It did not show burial, ritual, art, jewelry, or symbolic markings. It did not establish that the individuals were related or that they died at the same time. The evidence remains incomplete, and mining had permanently erased part of the archive. But Layer 7 provided enough coherence to answer the question that had brought the team back. Something had survived, and within that narrow remnant lay the means to redraw the chronology of Homo sapiens. The fire that once warmed the shelter eventually became the instrument that fixed Jebel Irhoud in time. Among the artifacts recovered from Layer 7 were pieces of flint that had been exposed to intense heat. To the people who used them, they were ordinary tools or fragments lying near a fire. To modern researchers, they contained a record of the last moment their mineral structure had been reset. That record could be read through thermoluminescence, a dating method especially valuable where radiocarbon could no longer reach. Minerals such as quartz and feldspar absorb energy from natural radiation in the surrounding sediment. Over time, electrons become trapped within imperfections in the crystal lattice. The longer the mineral remains buried, the more of this stored energy accumulates. Heating the material strongly enough releases the trapped electrons and empties the clock. Once the stone cools and is buried again, the process begins anew. In the laboratory, researchers can heat the sample and measure the faint light released as those trapped electrons escape. By comparing the stored signal with the radiation dose received from the environment, they can estimate how much time has passed since the stone was last heated. This is not a clock that produces a perfect anniversary. It depends on careful measurement of the surrounding radiation, the mineral composition of the artifact, the burial conditions, and the extent to which the original signal was fully reset. At Jebel Irhoud, the heated flints from Layer 7 yielded a weighted average age of about 315,000 years, with an uncertainty of 34,000 years. That result is often shortened to 315,000 years old, but the scientific finding is broader. The reported range extends roughly from 383,000 to 247,000 years ago, with 315,000 as the central estimate. The distinction matters because precision can easily be exaggerated in public retellings. The date does not mean that every fossil, tool, or animal bone at Jebel Irhoud was measured directly and proven to be exactly 315,000 years old. The thermoluminescence samples came from heated stone artifacts securely associated with the archaeological layer. Human fossils found within that same intact context are assigned to the age of the layer. Older discoveries, especially Irhoud 1, lack the same exact three-dimensional provenance because mining had disturbed their original positions. Their inclusion in the broader assemblage rests on geological history, morphology, and comparison with the securely excavated material. The separate evidence from Irhoud 3 helped support the new chronology. Its tooth had previously been dated by electron spin resonance combined with uranium series information. The earlier estimate, near 160,000 years, was later recalculated using a better model of the radiation environment derived from the renewed excavations. The revised result, about 286,000 years, with an uncertainty of 32,000 years, overlapped with the thermoluminescence age of Layer 7. The agreement was not exact, nor should independent methods be expected to produce identical central values. What mattered was that both placed the human presence far deeper in time than the old estimate of roughly 40,000 years. The implications were immediate. Before the 2017 publication of the new dates and anatomical analyses, Omoi in Ethiopia was widely treated as the oldest securely dated Homo sapiens fossil, then thought to be around 195,000 years old. Jebel Irhoud shifted the known early phase of the lineage backward by more than 100,000 years. Later work would show that Homo sapiens itself must be older than approximately 233,000 years, but the central estimate for Jebel Irhoud remained earlier. The two sites did not cancel one another. Instead, they reveal that early Homo sapiens populations were already diverse across Africa over a very long period. The date also transformed the anatomical puzzle. At 40,000 years, the long and low brain cases of the Irhoud people would have looked like an unexpectedly archaic survival in a world where more rounded Homo sapiens skulls were already widespread. Near 315,000 years. The same anatomy could be understood as part of an earlier stage in the development of the lineage. Their relatively modern facial structure had appeared before the rounded cranial shape typical of later humans. Time turned an apparent contradiction into evidence of mosaic evolution. The heated flints also carried a quieter lesson about archaeological interpretation. Fire at Jebel Irhoud was not important because these people were the first humans to control it. Evidence for fire use reaches much farther back. Nor does every burned artifact prove a formal hearth or a deliberate act of heating. Stones can be altered when fires are built above discarded tools, when activity areas are reused, or when flames spread through accumulated material. The exact sequence remains uncertain, yet whatever brought those flints into contact with heat, the event erased their previous luminescent signal and created the starting point for the clock later measured in the laboratory. This means that an ordinary episode of occupation preserved the site's chronology. A toolmaker shaped a core. A flake was struck, used, broken, or discarded. Fire burned nearby. Heat passed through the stone strongly enough to reset its mineral memory. Sediment covered it. For hundreds of thousands of years, natural radiation accumulated again within the crystal lattice. When archaeologists recovered the artifact, the light released in a laboratory connected that ancient fire to a numerical estimate. Scholars still debate details of Middle Pleistocene dating, species boundaries, and how broadly the age of Layer 7 should be applied to finds from the earlier excavations. No method eliminates every uncertainty. Sediments can move, radiation levels can vary, and assumptions must be tested. The strength of the Jebel Irhoud chronology comes from convergence intact stratigraphy, thermoluminescence from multiple heated artifacts, and the recalculated ESCR and uranium series evidence from Irhoud 3. Together, these lines of evidence do not remove uncertainty, but they narrow it enough to overturn the old chronology and establish that the human occupation belongs securely within the later Middle Pleistocene rather than the recent Ice Age. The result was not a birthday for Homo sapiens. Evolution does not begin on one measured day, and a population at one site cannot mark the sudden appearance of an entire species. The date establishes that people with a recognizably sapiens-like face and more archaic cranial form lived in northwestern Africa around 315,000 years ago. It pushes the known history of that anatomical combination deeper into the Pleistocene and forces the origin of our lineage to be understood as a longer process. For decades, the damaged quarry had withheld its age. The skulls seemed suspended between categories because they were suspended in time. Layer 7 changed that. The fossils, tools, butchered animals, and fire-heated stone could finally be placed within the same ancient interval. The mine had destroyed part of the archive, but the surviving flints preserved a clock in light, waiting beneath the limestone until the shelter's deepest significance could be measured. The date had placed the Jebel Irhoud population deep enough in time for their anatomy to be read in a new way. What had once looked like an awkward mixture of late and archaic features now appeared as a snapshot from an earlier stage of Homo sapiens evolution. The most striking contrast lay between the front and the back of the skull, viewed from the face. These people could seem unexpectedly familiar. Viewed from the side, their cranial shape remained markedly different from that of most humans today. The face was relatively short and sat beneath the brain case rather than projecting strongly forward. The central facial region lacked the distinctive protrusion associated with Neanderthals. The cheek area and general orientation of the face aligned more closely with Homo sapiens. This did not mean that an individual from Jebel Irhoud would have passed unnoticed in a modern crowd. Brow ridges were still robust. The lower face could be powerful, and the jaw lacked some derived features common in recent humans. Yet the underlying architecture of the face belonged to a pattern that became increasingly recognizable in later members of our lineage. Behind that face, however, the skull extended backward in a long, low form. The cranial vault was less rounded, the rear of the head less globular, and the overall profile more elongated than in most recent Homo sapiens. This difference was not simply a matter of having a smaller brain. Estimates suggest that brain volume fell within or near the range of our species. What differed most was shape. The same amount of neural tissue can be housed within skulls organized in different ways, and the Jebel Irhoud fossils show that a large brain did not automatically produce the rounded form seen in later humans. That distinction is important because skull shape is often mistaken for a direct measure of intelligence. It is not. Fossil bone cannot reveal a person's vocabulary, memory, imagination, or capacity for cooperation. Nor can an elongated brain case be ranked as a lower mental stage in any simple sense. The internal surface of the skull can preserve broad information about the brain shape, but it does not preserve thought. The evidence remains incomplete, and no responsible reconstruction can turn cranial geometry into a scale of human ability. Researchers studying virtual endocasts, digital models of the space once occupied by the brain, found that early Homo sapiens, such as the Jebel Irhoud people, had not yet developed the strongly globular pattern characteristic of recent humans. In later Homo sapiens, the parietal regions become relatively expanded, the posterior cranial vault becomes more rounded, and the relationship between the cerebrum and cerebellum changes. These shifts appear to have unfolded gradually after the basic facial pattern had already emerged. The human head did not modernize as one coordinated unit. This mosaic development changes the way species origins are imagined. A simple diagram might show an archaic human becoming a modern human as if an entire body transformed at once. The fossils tell a less orderly story. Facial proportions could change before cranial globularity. Dental development could resemble Homo sapiens while the lower jaw remained robust. Brain size could fall within a familiar range while brain shape retained an earlier organization. Traits appeared at different times, in different populations, and perhaps under different evolutionary pressures. Irhoud 1 and Irhoud 2 make this pattern visible, but Irhoud 10 allowed it to be tested through detailed three-dimensional reconstruction. Because the fossil had been crushed, researchers digitally separated and repositioned the surviving fragments before comparing the reconstructed face with Neanderthals, recent humans, and other fossil populations. The analysis placed the facial morphology close to Homo sapiens, while the neurocranial form remained more archaic. The result emerged from measurements across multiple anatomical landmarks. Variation among the fossils also mattered. Not every brow ridge had the same thickness. Not every preserved facial angle was identical. Some differences may reflect age, sex, or normal individual diversity, while others may come from distortion during fossilization. Irhoud 1 should therefore not be treated as the exact face of the entire population. The site preserves several people, not copies of one model. What unites them is a shared anatomical tendency rather than complete uniformity. The lower jaws reinforce that complexity. Irhoud 11 is large and strong, without the fully projecting chin seen in many recent humans. Yet the shape of the dental arcade, the organization of the jaw, and the teeth support placement within the early Homo sapiens lineage. A chin is only one feature among many, and its incomplete development does not exclude the fossil from our branch. Evolutionary classification depends on patterns across anatomy, not one checklist item. The same caution applies to the word modern. At Jebel Irhoud, modern-looking face is a comparative description, not a claim that these people were anatomically identical to humans today. Their soft tissues are unknown. Their noses, lips, ears, skin, hair, and facial expressions cannot be recovered from bone alone. No ancient DNA has survived to establish pigmentation or close genetic relationships. Artistic reconstructions can suggest possibilities, but they remain interpretations built around the skull rather than verified portraits. What the fossils show is that one of the most recognizable parts of the human form emerged early, around 315,000 years ago, in northwestern Africa. A face with broadly Homo sapiens proportions existed alongside a cranial vault that still carried a deeper evolutionary history. This combination suggests that selection acting on the face, jaws, teeth, development, and brain organization did not move at the same pace. Some changes may have been linked to diet or chewing mechanics. Others may have involved growth patterns, birth, or brain reorganization. Scholars still debate the causes, and no single explanation fully accounts for the sequence. The contrast between face and brain case also undermines the search for a single fossil that can be crowned the first true modern human. If the defining traits of Homo sapiens accumulated gradually, then any boundary placed within that process will be partly conventional. Earlier populations may possess some of the pattern, later populations more of it, and neighbouring groups may differ in which traits they retain. Jebel Irhoud sits near the base of that shifting arrangement, not as a finished form appearing suddenly, but as evidence that the assembly had already begun. Seen in profile, the skull remains long and low. Seen from the front, the face approaches something unexpectedly familiar. That tension is the central anatomical mystery of the site. It is also the reason the fossils matter beyond their age. They reveal that becoming Homo sapiens was not a single transformation, but a sequence of changes distributed across the body and across deep time, leaving behind faces that seem close to us beneath skulls that still belong to a humanity in motion. The face and brain case carried the most dramatic contrast at Jebel Irhoud, but the teeth and jaws preserved a quieter record of identity. They did not offer names, family relationships, or exact biographies. They could not reveal language, skin color, or the social roles of the people who used the shelter, yet they preserved growth, diet, anatomy, and variation. In a population known only from fragments, the mouth became a dependable guide to where these people belonged. Teeth survive because enamel is the hardest tissue in the human body. Their size, internal structure, wear, and pattern of development allow comparison across populations separated by immense spans of time. At Jebel Irhoud, the dental evidence repeatedly supports a close relationship with the Homo sapiens lineage. The teeth are not simply modern in every respect, but neither do they fit comfortably within the Neanderthal pattern. Their anatomy helps explain why the fossils are generally classified as early Homo sapiens, even while their skull vaults retain an older form. Irhoud 3 provides the most intimate developmental record. The specimen is a lower jaw from an immature individual whose teeth were still forming. Under magnification and through imaging, researchers could examine microscopic growth lines laid down in enamel and dentine. By counting and comparing them, researchers estimated an age of roughly 7.5 to 8 years. The result is scientifically valuable because childhood development differs among human lineages and can reflect broader patterns of growth. The dental schedule of Irhoud 3 appears closer to Homo sapiens than to more archaic humans. This suggests that at least some elements of the extended developmental pattern associated with our lineage were present surprisingly early. But the conclusion must remain narrow. One jaw cannot reconstruct an entire life history, and dental development cannot reveal how long social dependence lasted, how knowledge was taught, or how a group defined maturity. It gives a biological signal, not a complete account of childhood. The evidence remains incomplete, and any larger interpretation must be treated cautiously. Irhoud 11, the large adult mandible recovered from layer 7, offers a different puzzle. It is robust, with dimensions that would look powerful beside many recent human jaws. It lacks the fully expressed projecting chin common among much of living Homo sapiens. That absence once encouraged some researchers to treat similar fossils as too archaic for our species. Yet a chin is not a biological passport. Its shape varies, and species classification cannot rest on one feature alone. The total arrangement of the jaw, teeth, and surrounding anatomy matters more than the presence of a sharply defined mental prominence. The mandible combines ancestral and derived features. Its size and strength recall earlier humans, while aspects of its dental arcade and internal structure align more closely with Homo sapiens. This mixture mirrors the contrast already seen in the skulls. The people of Jebel Irhoud did not carry a complete package of modern traits. Their anatomy was assembled unevenly, with some regions changing earlier and others retaining older patterns. Teeth, face, jaw, and brain case were moving through evolution at different speeds. That unevenness makes species boundaries difficult to draw. Textbooks often present species as distinct branches separated by clean gaps. Fossils from the Middle Pleistocene rarely cooperate. Populations may exchange genes, remain isolated for long intervals, and reconnect later. Traits can spread without every part of the skeleton changing at once. A fossil may resemble Homo sapiens in the face and teeth, while retaining a cranial form that seems more primitive. Deciding where one species begins can therefore depend partly on which traits researchers consider most diagnostic. Most specialists place Jebel Irhoud within early Homo sapiens, or near the base of the Homo sapiens clade. Some prefer more cautious phrases because the anatomy falls close to a transition, and because the fossil sample is limited. The disagreement reflects a deeper question: whether species name should mark broad evolutionary lineages or only populations with a more complete set of later characteristics. No single explanation fully resolves that problem, because evolution itself does not create boundaries for classification. The jaws also reveal variation among individuals. Irhoud 3 belongs to an immature person, Irhoud 11 to an adult. Teeth from other individuals differ in wear, size, and preservation. Some variation may reflect age, sex, ordinary genetic diversity, or the effects of use. Other differences may result from damage and deformation after burial. The sample is too small to define the full range of the population. It would be a mistake to treat one jaw as the standard form of everyone who visited the shelter. Wear patterns offer limited clues about food and behavior. The teeth were used in a world without processed meals, metal tools, or agriculture. Meat, tough plant material, grit, and particles introduced during preparation could all contribute to wear. Yet the exact proportions of plant and animal foods remain unknown. The animal bones preserve evidence of gazelle and other ungulates, while plant remains are far less visible archaeologically. Dental wear can suggest demanding use, but it cannot produce a precise menu. Nor can the jaws establish close kinship. Without ancient DNA, researchers cannot determine whether any two individuals were parent and child, siblings, or unrelated visitors separated by generations. Similar anatomy reflects shared population history, not proof of family connection. The temptation to imagine a household around the fire is understandable, but the fossils do not preserve that relationship. At least 5 individuals are represented. Whether they knew one another cannot be demonstrated. The same absence of DNA limits other claims. Teeth sometimes preserve genetic material better than bone, but none has yielded a published ancient genome from Jebel Irhoud. More than 300,000 years in a warm climate is hostile to DNA survival. As a result, genetic sex, pigmentation, close ancestry, and direct links to living populations remain beyond reach. The mouth provides anatomy and development, not a genetic portrait. Still, the teeth and jaws carry a powerful evolutionary message. They show that the early Homo sapiens pattern extended deeper than facial appearance alone. Development, dental morphology, and mandibular structure all point toward our lineage, even while robust dimensions and incomplete chin formation preserve an older inheritance. These people were not anatomical replicas of recent humans, but neither were they outsiders to the story. In the end, the hidden identities of Jebel Irhoud remain exactly that hidden. The fossils cannot tell us what individuals called one another, or how they understood their place in the landscape. They offer no names and no direct family tree, but in the slow growth of enamel and the architecture of a jaw, they preserve something broader. They record a population near the beginning of Homo sapiens, carrying familiar biological rhythms within bodies that had not yet taken on the final shape of later humanity. The biological rhythms preserved in teeth belong to people moving through a landscape that was never static. Around Jebel Irhoud, climate shaped almost every possibility where gazelles gathered, where water persisted, when vegetation spread, and whether human groups could cross regions that later became difficult or impossible to traverse. The modern surroundings look dry and exposed, but projecting that appearance into the Middle Pleistocene would distort their world. Animal remains provide the strongest clues. Gazelles dominate much of the large faunal assemblage, joined by other hoofed mammals such as alcelephine antelopes, equids, and wild bovids. Rodents add another signal because many species occupy narrow ecological niches. Together, the evidence suggests open country with grassland, patches of scrub, and conditions less arid than those characterizing some later phases. It was not a tropical forest, and it was not an endless green plain. It was a variable mosaic shaped by changing rainfall. Water may have been seasonal or available beyond the shelter. The record preserves no detailed map of streams, pools, or plant communities. Yet humans and the animals they hunted required dependable access to water. The concentration of gazelle and other game suggests a landscape productive enough to support repeated movement through the region. Jebel Irhoud was therefore not an isolated refuge in a dead desert, but one point within a broader ecological network. That network extended far beyond western Morocco. During wetter phases of the Pleistocene, the Sahara could support lakes, rivers, grasslands, and animal corridors. Regions now separated by great distances of arid terrain could become more connected. Ungulates moved with vegetation. Predators followed prey. Human populations could expand into areas previously difficult to occupy. When rainfall weakened, those routes contracted. Lakes shrank, grasslands fragmented, and populations could become separated in ecological refuges along coasts, mountains, river basins, or better watered zones. This repeated opening and closing of the continent offers a plausible mechanism for the uneven evolution visible in the fossils. Groups separated for long periods could develop regional differences. Later climatic improvement might bring them into contact again, allowing genes, technologies, and learned behaviors to move between populations. The process would not resemble one migration sweeping outward from a single point. It would be a network of expansions, retreats, isolation, and reconnection unfolding over immense spans of time. Scholars still debate how directly particular wet phases can be linked to specific fossil populations. Jebel Irhoud cannot be assigned with certainty to one precisely mapped corridor or migration pulse. The date of approximately 315,000 years carries a broad uncertainty range, and African climate records vary between regions. It is therefore safer to speak of recurring ecological opportunities than to draw a single route across the map. What survives in the record suggests that North Africa alternated between being a bridge and a barrier. Its people lived within that alternating geography, though its exact pathways remain unknown. The people who used the shelter would have known these changes not as climate cycles measured in sediments, but as practical realities. A familiar water source could become unreliable. Herds might shift their seasonal path. Useful stone could require a longer journey. New patches of grazing land could open beyond a previously dry zone. Human movement would follow knowledge accumulated through repeated experience, observation, and social transmission, even without reconstructing language or symbolic maps. The transport of raw material over perhaps 30 kilometers shows that the Irhoud population operated across a landscape larger than the immediate cave. The shelter itself offered a useful position within that range. Its shallow limestone protection could provide shade, wind cover, and a place to process food or maintain tools. From nearby open ground, hunters could observe animal movement. Yet the site does not reveal whether people stayed for days, returned seasonally, or revisited it across generations. The relatively low number of small flakes and the higher proportion of retouched tools may indicate that many implements arrived already prepared. If so, Jebel Irhoud was one station within a mobile system rather than the center of a permanently occupied territory. Gazelle formed an important part of that system. Their abundance in the faunal remains reflects both their presence in the landscape and human decisions about hunting or carcass processing. Gazelles are alert, fast, and well adapted to open environments. Acquiring them regularly would require knowledge of terrain, herd behavior, and timing. The bones show cut marks, impact damage, and fractures made while fresh, indicating removal of meat and access to marrow. These activities reveal planning and skill, though they do not tell us exactly how animals were hunted. Other resources have largely disappeared. Plant foods leave a much weaker archaeological signature than bone, especially across more than 300,000 years. Roots, seeds, fruits, leaves, and other gathered foods may have contributed significantly, but their proportion cannot be measured from the surviving assemblage. The prominence of gazelle should therefore not be mistaken for proof of a meat-only diet. Preservation favors the durable parts of certain meals and erases much of the rest. Ostrich eggshell adds another small clue to the open setting. Its presence confirms that these large birds formed part of the regional fauna, but it does not establish that the shells were used as containers, ornaments, or symbolic objects. Later African sites preserve modified ostrich eggshell, yet no such interpretation is secure here. At Jebel Irhoud, the fragments belong first to the environmental record, not to a story of art or ritual. The wider landscape also shaped contact between human populations. Western Morocco faced the Atlantic, while routes to the east and south depended on changing belts of vegetation and water. The Strait of Gibraltar lay to the north, but no evidence shows that the Jebel Irhoud population crossed into Europe. Their location near the continent's northwestern edge should not be turned into an unsupported migration narrative. Geography created possibilities, not proof. What the site does establish is that early members of the Homo sapiens lineage lived far from the East African locations once treated as the exclusive centre of human origins. Their presence in Morocco indicates a broad African distribution by this time. Similarity among distant populations could result from shared ancestry, intermittent contact, or parallel retention of older traits. Difference could reflect isolation, local adaptation, or ordinary variation. No single explanation fully accounts for the pattern. The changing country beyond the shelter therefore becomes part of the anatomical story. The familiar face and elongated skull did not evolve in stillness. They belong to populations responding to shifting grasslands, broken corridors, recurring drought, and renewed connection. Climate did not create Homo sapiens by itself, but it repeatedly rearranged the populations from which Homo sapiens emerged. Across this unstable Africa, separation preserved differences, movement mixed them again, and the long human lineage took shape within a landscape that never held one form for long. The changing landscape brought people to Jebel Irhoud, but the shelter became visible to archaeology through the work they left behind. Stone tools, heated flint, butchered animal bones, and broken marrow-rich limbs form the practical record of their presence. These traces do not reveal a complete culture or justify claims of art and ritual. What they show is planning materials chosen in advance, cores prepared with care, carcasses processed systematically, and fire used within a place that may have been visited repeatedly. The stone industry belongs to the African Middle Stone Age. Earlier researchers had called parts of it Mousterian, because some artifacts resembled European prepared core technologies associated with Neanderthals. That label carried more biological meaning than the tools could support. At Jebel Irhoud, the more useful description centers on Levallois reduction, a method in which a stone core is shaped so that a desired flake can be removed with a controlled final strike. The sequence requires an understanding of angles, convexities, striking platforms, and the relationship between preparation and result. Levallois technology is often described as evidence of foresight, and that is fair within limits. A napper must hold a goal through several steps and recognize how each removal changes the core. Yet it should not be treated as proof of language, mathematics, or symbolic thought in a modern sense. Skilled stoneworking reveals procedural knowledge without telling us how that knowledge was taught. The tools preserve action, not conversation. The assemblage includes points, flakes, scrapers, retouched pieces, and prepared cores made from flint, quartzite, and quartz. Some tools could have cut flesh, opened hides, shaped wood, or served in tasks that leave little trace. Points may have been used by hand or attached to shafts, but no preserved hafting system confirms a particular weapon design. There is no secure evidence for bows, arrows, metal, ground agricultural tools, or the specialized blade industries that appear much later. The technology must be described on its own terms. Raw material carries the story beyond the shelter. Part of the flint may have come from the Jebel Irhoud area roughly 30 kilometers to the south. That distance suggests that the people of Jebel Irhoud knew a broad territory and valued stone with predictable fracture qualities. They may have visited the source directly, transported prepared cores, or received material through contact with others. The evidence cannot distinguish among those possibilities. It does establish that useful stone did not always enter the site by chance from immediately outside. The pattern of artifacts may also reflect mobility. Small waste flakes are relatively limited, while retouched tools are common enough to suggest that some implements arrived already shaped. People may have carried a portable tool kit, maintained it during a stay, and taken usable pieces away again. A shelter used in this manner would fit within a wider circuit of movement involving water, game, raw material, and seasonal opportunity. Whether each occupation lasted hours, days, or longer remains unresolved. Fire altered that practical world. Heated flints from Layer 7 provided the thermoluminescence date, but for their makers, fire served immediate needs. It could offer warmth, light, protection, and a means of changing food or materials. Nor does every burned stone prove a carefully built hearth. Discarded artifacts may have lain beneath later fires, and repeated occupations could have mixed activity surfaces. Still, the concentration of heated material supports fire use within the shelter. The special significance of that fire lies in what it does not prove. These people were not the first humans to control flames. Fire use has a much older history. Jebel Irhoud does not reveal how fires were started, whether embers were carried, or whether flames were maintained continuously. It records presence and heating, not invention. Its scientific importance comes from the way heat reset the mineral clock within the flint, allowing an ordinary camp activity to preserve a date across hundreds of millennia. Animal bones bring the occupants closer. Gazelle dominates the preserved assemblage, accompanied by other ungulates, including larger antelopes, equids, and bovids. Cut marks show that stone edges were drawn across carcasses to remove flesh. Impact marks and fresh fractures on long bones indicate deliberate breakage, probably to reach marrow. These patterns support the conclusion that humans, rather than carnivores, were the principal agents accumulating much of the large animal material in the layer. Yet the bones do not reveal exactly how the animals were acquired. Gazelles could have been hunted near the shelter, intercepted along movement routes, or brought from some distance as whole carcasses or selected portions. the site lacks the evidence needed to reconstruct one favoured technique. Points may have formed part of hunting equipment, but the connection is not direct enough to describe a specific chase or weapon with certainty. What survives suggests knowledgeable exploitation of open country game, not a detailed scene. Marrow extraction reveals economical use of carcasses. Long bones were valuable containers of fat and nutrients, especially when other food sources fluctuated. Breaking them while fresh required force, suitable hammer stones, and familiarity with where the richest cavities lay. It was practical and efficient, part of a broader pattern seen among many prehistoric humans. At Jebel Irhoud, it shows that the inhabitants did more than cut meat from accessible surfaces. Gazelle bones dominate because durable animal remains preserve well, not because every meal consisted of meat. Plant foods rarely survive under the same conditions. Fruits, seeds, roots, leaves, and other gathered resources may have been important, but their contribution has largely vanished. Ostrich eggshell occurs at the site, though its presence does not prove use as a container, ornament, or symbolic object. Later African contexts preserve such modifications. Jebel Irhoud does not securely do so. This distinction between demonstrated skill and imagined culture is essential. Planned stone reduction, transport of raw material, fire use, butchery, and marrow extraction all reveal capable people organizing activity within a landscape they understood. They do not automatically establish beads, burial, religion, painting, music, or syntactically modern language. No secure artistic or ritual evidence has been found at the site. Technological planning is real, but behavioral modernity is not a single package inferred from one tool tradition. Around the hearth, archaeology offers movements rather than personalities, a core turned in the hand, a prepared surface struck, an edge resharpened, a gazelle limb opened, a flint accidentally heated and left behind. These actions are ordinary enough to feel almost familiar, yet they occurred more than 300,000 years ago, performed by people whose faces approached our own, while their skulls retained an older shape. Their tools do not complete their portrait, but they reveal disciplined intelligence applied to stone, fire, food, and distance in a world where survival depended on understanding how those elements fitted together. Those disciplined actions bring the people of Jebel Irhoud closer, but only to a point. Stone can preserve a sequence of blows, bone can preserve a cut mark, teeth can preserve growth, none preserves a voice, a gesture, or a remembered name. Their daily lives must be reconstructed from traces that are both intimate and incomplete. The temptation is to fill the silence with familiar scenes, but the strongest account begins by respecting what remains unknown. Their appearance cannot be recovered as a complete portrait. The skulls provide broad proportions of the face, brow, jaw, and brain case, yet soft tissue changes how a person actually looks. The thickness of lips, shape of ears, width of the nose in life, and countless small variations are not preserved. No ancient DNA has been recovered from Jebel Irhoud, so pigmentation, eye color, and hair texture cannot be directly identified. Artistic reconstructions may choose these features, but those choices remain possibilities rather than measured facts. Even the bones require caution. Irhoud 1 is the best-known skull, but it should not become the standard face of the entire population. Irhoud 2 differs in several details. Irhoud 10 was crushed and reconstructed digitally. Brow ridges vary, and the preserved jaws do not represent the same age. Some differences may reflect sex, age, individual variation, or geological distortion. What survives suggests recognizably different people, not identical figures with one shared expression. Their bodies are still harder to estimate. A humerus, part of a pelvis, a femur fragment, ribs, and vertebrae offer limited information, but the assemblage is too incomplete to provide secure heights, weights, or builds for every individual. It would be misleading to describe them all as uniformly tall, heavily muscled, or physically identical. Their skeletons probably reflected mobile life, but the degree of daily travel, division of labor, and physical variation remain uncertain. Their routine was probably shaped by repeated decisions rather than permanent settlement. A group arriving at the shelter might repair tools, divide usable stone, process an animal, or rest before moving again. These are plausible activities supported by the assemblage, but the sequence, duration, and number of visits cannot be recovered. Behavior is known through repeated practical choices. Levallois reduction shows that toolmakers understood how a sequence of removals could produce a useful flake. Transported stone indicates knowledge of sources beyond the shelter. Butchery marks show controlled use of sharp edges. Broken long bones reveal access to marrow. Fire-heated flint places combustion within the activity area. Together, these traces suggest coordination and learned skill. Complex techniques normally persist because knowledge passes through demonstration, observation, correction, or other forms of communication. That inference does not prove that they spoke a language identical in structure to those used today. Archaeology cannot recover syntax from a stone core, nor can it determine the words, calls, gestures, or teaching methods through which knowledge moved. Still, the consistency required by prepared core technology makes effective social learning highly likely. A novice must recognize suitable raw material, understand the order of preparation, control force and angle, and know when a core has ceased to be useful. Those abilities are learned socially, even if the exact environment is lost. Cooperation is also suggested by the acquisition and processing of animals, though the scale of group action cannot be reconstructed. Gazelles can sometimes be taken by one skilled hunter, while larger ungulates may require greater coordination. Carcasses may have been shared, transported in parts, or processed where they fell. The bones do not preserve the hunt itself. They preserve later stages cutting, breaking, and consumption. Scholars still debate how much can be inferred, and no single explanation fully accounts for every animal represented. The shelter may have supported activities divided among individuals, but archaeology cannot assign fixed roles by age or sex. It is easy to imagine one person hunting, another making tools, and others tending fire, yet the evidence does not identify who performed which task. Skills may have overlapped. People may have shifted roles depending on season, health, opportunity, or experience. Flexibility may have mattered as much as specialization, but the balance remains beyond recovery. Care within the group is harder to detect. The presence of different ages establishes that the population included people at different life stages, but it does not reveal family structure. Irhoud 3 records an immature individual through a preserved jaw, while other fossils belong to adults. These remains cannot establish that they lived together, died together, or were related. No genetic evidence links them, and no burial arrangement holds them in a single social scene. A family gathered in the shelter would go beyond the record. Still, prolonged human development generally depends on learning and protection within a social group. The dental growth pattern of Irhoud 3 resembles that of Homo sapiens more than that of earlier humans in some respects, hinting that extended development had deep roots. The safest conclusion is not to invent a childhood, but to recognize that a slowly developing individual would have lived within networks of dependence and teaching. The details remain silent. Their emotional lives are inaccessible through fossil form. A modern-looking face does not prove modern emotions, just as an elongated brain case does not imply their absence. Attachment, grief, humor, fear, patience, and rivalry do not fossilize. It would be equally unjustified to portray these people as emotionally identical to us or as cold, primitive beings. They belong to an early branch of our lineage, but the texture of their inner lives cannot be measured. The same restraint applies to symbolism. Jebel Irhoud preserves no secure beads, engravings, burials, ritual objects, or cave art. Its people may have possessed traditions that left no durable trace, but possibility is not evidence. Planned technology should not be promoted automatically into religion or art. Later North African sites preserve clearer symbolic objects, including modified shells, but those developments cannot be projected backward by more than 100,000 years. What remains is neither a complete portrait nor an empty one. The people of Jebel Irhoud moved through a broad landscape, selected stone, maintained tools, used fire, processed animals, and passed difficult skills between generations. They varied in age and anatomy. They likely depended on one another, though the structure of that dependence is unknown. They had faces whose basic architecture approaches ours, but no surviving image tells us how those faces looked in firelight. Their lives appear through verbs rather than descriptions, carrying striking, cutting, watching, learning, returning. These actions reveal capable people without pretending to know them completely. The distance between evidence and imagination remains wide, but it is not empty. Within it stands a population organized well enough to endure a changing landscape, leaving behind not a portrait of who they were, but a pattern of what they knew how to do. The practical knowledge visible at Jebel Irhoud belongs to a larger question: where, exactly, did Homo sapiens emerge? For much of the 20th century, the answer was often compressed into a simple image. A relatively small population in East Africa acquired the defining anatomy of modern humans, then expanded across the continent and eventually beyond it. The model was attractive because it offered a single center, a clear sequence, and a beginning that could be placed on a map. Jebel Irhoud did not erase East Africa from the story, but it made that simplicity increasingly difficult to defend. Around 315,000 years ago, people with many features of the Homo sapiens face, jaw, and teeth were living in northwestern Africa. Their skulls were not fully modern in shape, yet they belonged close to the base of our lineage, at roughly the same broad period. Other African regions preserve fossils with different combinations of familiar and archaic traits. The pattern suggests that the emergence of Homo sapiens may have involved several populations distributed across the continent, rather than one isolated group changing in complete separation. This idea is often called a Pan-African model, but the phrase can be misunderstood. It does not mean that Homo sapiens evolved independently in many places as separate inventions. Nor does it mean that every population across Africa changed in exactly the same way at the same time. Instead, it proposes a structured history. Populations could remain partly isolated, develop regional differences, and later reconnect when climate opened routes between them. Gene flow and cultural exchange could then move traits across the continent without erasing all local variation. Jebel Irhoud fits this model because it demonstrates that early sapiens-like anatomy existed far from the eastern sites once treated as the sole centre of origin. The Moroccan fossils do not show a complete modern form, and that incompleteness is important. They reveal that some components of the Homo sapiens pattern were present in one region, while other traits continued to evolve elsewhere or later. The species may have taken shape through the gradual combination of features carried by interconnected populations rather than through one sudden transformation. Climate would have helped regulate those connections. Wetter periods could turn parts of the Sahara into grassland crossed by rivers, lakes, animals, and people. Drier phases could fragment those routes and leave groups separated in more habitable zones. Isolation would allow local variation to deepen. Reconnection would allow genes and technologies to spread over hundreds of thousands of years. Repeated cycles of separation and contact could create a lineage that was both diverse and linked. Genetic research on living populations supports a similarly complex history, though it cannot identify the Jebel Irhoud people as direct ancestors. No ancient DNA has been recovered from the site. Modern genetic models instead suggest that the ancestry of living humans cannot be explained easily by one tiny, completely isolated source population. One proposal describes a weakly structured stem. Several ancestral populations remain distinct enough to develop differences, yet connected enough for gene flow to continue over long periods. This is not a perfect reconstruction of the Middle Pleistocene, but it offers a framework consistent with the uneven fossil record. The phrase stem can also mislead if imagined as one straight trunk. The ancestral population of Homo sapiens may have resembled a braided river, with channels separating, rejoining, and changing strength through time. Some branches may have contributed heavily to later populations. Others may have disappeared or left only limited traces. Jebel Irhoud represents one surviving glimpse of that network, not the entire network itself. Other fossils help reveal the broader pattern. Omoi in Ethiopia, now known to be older than approximately 233,000 years, has a more modern combination of cranial features than the central estimate for Jebel Irhoud would lead one to expect from a simple linear sequence. Herto, also in Ethiopia, and younger than Omoi, preserves a robust form of Homo sapiens with its own mixture of traits. Florisbad in South Africa, often dated to around 260,000 years ago, presents another mosaic and remains debated in classification. Each site records a local population and a different point within the wider process. These fossils should not be arranged as a neat ladder leading from one to the next. Jebel Irhoud was not necessarily ancestral to Omoi. Omoi was not necessarily ancestral to Herto. Florisbad does not fill a single predetermined gap. The populations may have shared deeper ancestry, exchanged genes indirectly, or represented branches with different long-term contributions. The evidence remains incomplete, and the fossil record is too sparse to trace a continuous line between them. The same caution applies to fossils beyond Africa. Homo sapiens remains at Mislia Cave in the Levant date to roughly 177,000 to 194,000 years ago, while the interpretation of a skull fragment from Apodema in Greece suggests a possible sapiens presence around 210,000 years ago. These finds show that early expansions beyond Africa occurred before the later dispersal that contributed most ancestry to living non-African populations. They do not prove that the travellers came directly from Jebel Irhoud or followed a route from Morocco across the Strait of Gibraltar. The Pan-African model therefore changes the scale of the origin story. Instead of asking for one birthplace, it asks how populations across a vast continent remain connected enough to belong to the same evolving lineage. Instead of searching for one first modern human, it examines when different anatomical and behavioral traits appeared, spread, and combined. Instead of treating regional variation as noise, it recognizes variation as part of the process. Jebel Irhoud supports this broader view, but one site cannot prove the entire model. Its fossils show an early presence of sapiens-like anatomy in North Africa. They do not reveal the genetic structure of all African populations, the exact direction of gene flow, or which groups contributed most to people living today. Scholars still debate how much continuity existed between regions, and whether some populations remained isolated for especially long periods. What the site changes is the burden of explanation. Any model of Homo sapiens origins must now account for a population in western Morocco around 315,000 years ago, carrying a relatively modern face beneath an elongated skull. It must also account for different combinations of traits in eastern and southern Africa. A single small cradle can no longer contain all of that evidence comfortably. The continent itself becomes the stage coastlines, highlands, river basins, grasslands, and shifting desert margins holding populations that were never permanently united and never entirely separate. Across that immense and changing geography, the components of Homo sapiens accumulated, moved, and recombined. Jebel Irhoud does not point to one birthplace. It points toward a long African network in which humanity emerged through connection, difference, and time. The African network implied by Jebel Irhoud becomes clearer when its fossils are placed beside other early members of the Homo sapiens lineage. The comparison does not produce a clean succession. It produces overlapping forms, each preserving a different combination of traits, and each forcing researchers to decide whether variation represents geography, time, ancestry, or simply the incompleteness of the fossil record. Omoi in Ethiopia remains one of the most important comparisons. The fossil is older than approximately 233,000 years. Its anatomy is in several respects more recognizably modern than the central estimate for Jebel Irhoud might suggest in a simple progression. The cranial vault is more rounded, and the face belongs more clearly within later Homo sapiens morphology. If evolution followed one straight sequence, an older-looking population should always precede a more modern-looking one. The fossils do not behave that way. This mismatch can be explained in several ways. Jebel Irhoud and Omo may represent regional populations evolving in parallel. One could have retained an elongated brain case while another developed greater cranial globularity. They may have shared ancestry but experienced different histories of isolation and contact. The evidence remains incomplete, and no single explanation fully accounts for the pattern. Herto, also from Ethiopia and dating to roughly 160,000 years ago, adds another mosaic. The fossils possess a combination of modern and archaic features, though in a form distinct from Jebel Irhoud. Their younger age does not make them simply more modern in every respect. Robustness, cranial form, and local population history complicate any ladder arranged from primitive to advanced. Florisbad in South Africa deepens the problem. The partial cranium, often dated to around 260,000 years ago, has been assigned variously to Homo sapiens, Homo helmae, or an intermediate African population near the ancestry of later humans. Its incomplete preservation leaves important regions uncertain, but the surviving face and brain case again show a mixture rather than a finished anatomical package. Whether Florisbad belongs inside Homo sapiens depends partly on how broadly the species is defined. Other African fossils occupy similarly contested positions. Some are too incomplete for confident placement. Others have uncertain dates or geological contexts. Together, they show that the Middle Pleistocene population landscape was not empty between an archaic ancestor and later modern humans. It was populated by regional forms sharing some traits while differing in others. One interpretation treats these fossils as stages within a single, broadly distributed Homo sapiens lineage. Under this view, Jebel Irhoud lies near the early end, with facial and dental traits already established while cranial globularity remained incomplete. Later fossils show additional changes accumulating through time. It recognizes that species evolve gradually, and that early members need not resemble later ones in every detail. A competing interpretation draws the boundary more narrowly. Researchers using stricter anatomical criteria may regard some Middle Pleistocene fossils as populations close to Homo sapiens, but not yet fully within the species. They may describe Jebel Irhoud as an early member of the sapiens clade, a stem population, or a group near the base of the lineage. This approach emphasizes substantial differences in brain case shape, chin development, and other features. The disagreement is not merely about names. It reflects different ideas about what a species label should accomplish. If Homo sapiens includes all populations descending from the branch after its separation from the Neanderthal Denisovan lineage, then a broad definition is reasonable. If the name is reserved for populations possessing a more complete suite of derived anatomy, then Jebel Irhoud may sit at the threshold. Fossils do not preserve reproductive boundaries, and no DNA from the site can show how genetically distinct the population was. Ancestry creates a second problem. Even if Jebel Irhoud belongs within Homo sapiens, that does not make its people direct ancestors of later humans. A population can belong to a lineage while representing a side branch that leaves little or no surviving ancestry. The known individuals may have come from a regional population that later mixed with others, declined, or disappeared. Without ancient DNA and a denser sequence of fossils, direct descent cannot be traced. Population structure offers a way to reconcile continuity with regional difference. In a structured African metapopulation, groups could remain separated long enough to develop distinctive anatomy while continuing to exchange genes intermittently. Under this model, no single fossil population needs to be the sole ancestor. Traits could arise in one region, spread through contact, and combine with features evolving elsewhere. The eventual anatomy of later Homo sapiens would be the product of repeated interaction rather than replacement by one local group. The weakly structured stem model derived from genetic data points in a similar direction. It proposes that ancestral populations remained connected over long periods, instead of splitting into completely isolated branches. Yet genetic models are not maps of named fossil sites. They cannot identify Jebel Irhoud, Omo I, or Florisbad as specific source populations. The connection is inferential. Both genetics and fossils resist a story of one small, isolated origin. Even broad agreement leaves the actual relationships among these populations difficult to resolve. Fossil samples are tiny compared with the populations they represent. Geological dates carry ranges. Preservation can exaggerate differences when only certain parts survive. Sex, age, and individual variation may be mistaken for evolutionary distance. Digital reconstruction can correct distortion, but cannot restore every missing feature without assumptions. A continent-wide model may fit the evidence, but its roots and contributions remain only partly visible. The newest Moroccan evidence extends the puzzle farther back. Fossils from Thomas Quarry 1 in Casablanca dated to around 773,000 years ago, reveal a North African population often described as Homo erectus in a broad sense, with a mixture of primitive and more derived traits. They occupy a period near the deeper separation of the later human lineages, but they cannot yet be linked directly to Jebel Irhoud. Hundreds of thousands of years and major gaps lie between them. Their presence matters because it shows that North Africa held important human populations long before the faces at Jebel Irhoud appeared. It suggests continuity of occupation at a regional scale, but not a proven local evolutionary sequence. The ancestors of the Irhoud population could have come from elsewhere, mixed with resident groups, or emerged from networks spanning much of Africa. The puzzle of human beginnings therefore remains a problem of connection. Jebel Irhoud, Omoi, Herto, Florisbad, and other fossils are not separate answers. They are fragments of one uneven process. Their differences do not weaken the story of Homo sapiens, they reveal its true shape. Humanity did not emerge as a finished form stepping from one place into the world. It took shape through populations that were related but not identical, separated but not always isolated, and preserved only in rare pieces scattered across a continent. The scattered fossils across Africa reveal a connected process, but Jebel Irhoud also demonstrates how much of that process remains inaccessible. Its importance can make the site seem more complete than it is. In reality, the evidence survives in fragments, portions of skull, jaws, teeth, a few limb bones, damaged sediments, heated flint, and animal remains. From those materials, researchers can reconstruct anatomy, technology, diet, and chronology with impressive precision. Yet every reconstruction rests against a wide field of absence. The most obvious missing evidence is ancient DNA. More than 300,000 years in a warm North African environment is a severe test for genetic preservation. Heat, moisture, microbial activity, and chemical change gradually break DNA into pieces too small or too altered to recover. No published genome has been obtained from the Jebel Irhoud fossils. Without it, researchers cannot directly establish genetic sex, close kinship, population relationships, pigmentation, hair form, or links to any living community. This absence is especially important because genetic data have transformed other parts of human origins research. Ancient genomes from Neanderthals and Denisovans revealed population splits, interbreeding, and migrations that anatomy alone could not resolve. Jebel Irhoud offers no equivalent window. Its position within early Homo sapiens rests on morphology and archaeological context, not on genetic confirmation. Modern genetic models can suggest that African ancestry was structured and interconnected, but they cannot identify the Irhoud population as a specific ancestral source. The fossils themselves are incomplete. Around 22 published specimens represent at least 5 individuals, but there are no complete skeletons and no full set of remains from one person. Some bones come from the renewed excavations, while others were recovered during earlier work or mining. Irhoud 1 lacks a precisely documented original position. Irhoud 10 required digital reconstruction after geological pressure crushed and distorted its fragments. Each specimen contributes information, but none provides an entire body. There is also a preservation bias within the human sample itself. Teeth and dense cranial bone endure more readily than fragile elements, so the surviving collection may exaggerate the importance of heads and jaws in the original deposit. The absence of hands, feet, and many smaller bones does not prove they were never present. It may reflect decay, sediment movement, recovery history, or the destructive effects of mining long before systematic excavation began. Incomplete bodies make many ordinary questions impossible to answer. Height and mass cannot be estimated securely for the group. Differences between males and females cannot be mapped with confidence. The condition of joints, muscles, and movement is only partly visible. Researchers cannot determine whether the individuals shared similar builds or represented a wider range of physical variation. Soft tissues, which shape most of a living face, are entirely gone. The way the remains accumulated is also uncertain. Human fossils occur within an archaeological context containing tools, animal bones, and traces of fire. But the site does not preserve a formal burial. There are no clear graves, grave goods, or arranged bodies. The individuals need not have died at the same time, and they need not have known one another. Their bones may have entered the deposit through different events separated by years, generations, or longer intervals. Mining damage makes this problem harder. Parts of the original shelter and its sediments were removed before modern excavation. Disturbed material may have shifted from one position to another. Although Layer 7 preserves a relatively intact association, the earliest finds cannot be assigned to it with the same precision as the later fossils. Geological movement, trampling, erosion, and repeated human use could all have altered the original pattern. No single explanation fully accounts for the accumulation. The lack of burial evidence also limits interpretation of death and social behavior. It would be unjustified to describe Jebel Irhoud as a cemetery, a mass grave, or a place of ritual deposition. The fossils do not show that the group died in one catastrophe, or that carnivores killed them, nor do they demonstrate deliberate abandonment or ceremonial treatment. The safest conclusion is that human remains became incorporated into deposits associated with occupation, while the exact sequence remains unknown. Classification introduces another uncertainty. The 2017 analyses place the fossils within Homo sapiens because the face, jaws, and teeth share derived features with our lineage. Many researchers accept the label early Homo sapiens. Others prefer phrases such as an early member of the Homo sapiens clade or a population near the base of the lineage. These alternatives do not necessarily reject the fossil's importance. They reflect disagreement over how broadly the species should be defined. A narrow definition emphasizes the elongated cranial vault, incomplete chin development, and non-globular internal brain case. A broader definition emphasizes shared ancestry and the sapiens-like organization of the face and teeth. Both approaches confront the same problem: species boundaries are imposed on populations that changed gradually. Fossils do not preserve mating behavior, reproductive isolation, or the movement of genes. Without DNA, the biological boundary is even harder to test. Dating also carries uncertainty, despite the strength of the evidence. The weighted thermoluminescence age of 315,000 years includes an uncertainty of 34,000 years. It dates heated flint from Layer 7 rather than every fossil directly. The recalculated ESR and uranium series result for Irhoud 3 supports an age near 286,000 years, but also includes a substantial error range. These methods converge on great antiquity, yet they do not produce one exact year. Behavioral reconstruction is equally limited. Planned Levallois technology demonstrates foresight and learned skill, but it does not prove art, ritual, religion, or fully modern language. Butchery marks demonstrate carcass processing, not a complete hunting method. Gazelle bones reveal preserved food remains, not the full diet. Fire-heated flints show exposure to flames, not how fires were started or maintained. Every strong inference has a boundary beyond which the evidence becomes speculation. Even the site's place in a Pan-African origin model must be handled carefully. Jebel Irhoud supports the presence of early sapiens-like populations in North Africa, but one locality cannot prove every connection across the continent. It does not identify the direction of gene flow or the ancestry of later populations. The newly described fossils from Thomas Quarry deepen Morocco's record, yet they do not create a demonstrated line of descent to Jebel Irhoud. The power of the site comes from what survives despite these limits: a damaged shelter, incomplete fossils, and altered stones were enough to overturn an old chronology and widen the geography of Homo sapiens' origins, but they do not close the story. Jebel Irhoud remains a rare window framed by missing evidence. Through it, researchers see a population near the threshold of our lineage, while beyond the frame lie the unknown faces, movements, relationships, and generations that would be needed to turn that glimpse into a complete history. The narrow window at Jebel Irhoud does not close with a final identification. It opens onto a deeper and more complicated history in which Homo sapiens cannot be reduced to one birthplace, one population, or one sudden anatomical transformation. The fossils from Western Morocco change the scale of the question. They showed that around 315,000 years ago, people with a broadly familiar facial architecture were already living near the Atlantic edge of North Africa, while the shape of their skulls still preserved an earlier stage in the evolution of our lineage. That discovery pushed the known history of Homo sapiens backward by more than 100,000 years compared with the chronology commonly accepted before 2017. Yet its greatest importance is not simply numerical. A date can be added to a timeline and forgotten. Jebel Irhoud is harder to contain because its anatomy resists a clean boundary. The face, jaws, and teeth point toward Homo sapiens. The elongated cranial vault and non-globular brain case point toward a form not yet identical to later humans. These people stood within our lineage while still revealing how incomplete the modern pattern remained. Their fossils therefore weaken the search for a single first person who can be called fully human in the modern sense. There was no visible instant when every defining trait appeared together. The evidence instead suggests a long mosaic process. Facial structure changed. Dental development followed its own trajectory. The chin remained incomplete. Brain size became large before the brain case assumed its later rounded form. Across Africa, different populations carried different combinations of these traits, and those combinations shifted through isolation, movement, and renewed contact. Jebel Irhoud also changed the geography of human origins. It did not replace East Africa with Morocco, and it did not prove that the Western Maghreb was humanity's sole cradle. Homo I, Herto, Florisbad, and other African fossils remain essential because each preserves a different part of the emerging pattern. Their differences are not obstacles to one true origin story. They may be the origin story a continent of structured populations, sometimes divided by aridity and distance, sometimes reconnected by wetter corridors, exchanging genes and knowledge across time spans far longer than any remembered history. The people at the shelter were part of that continental process, but their direct descendants cannot be traced. No DNA survives to connect them securely with the later population. They cannot be identified as the ancestors of present-day North Africans, of all living humans, or of the early Homo sapiens who later moved beyond Africa. Their lineage may have contributed widely, locally, or scarcely at all. Membership in the early Homo sapiens branch does not guarantee direct ancestry. Evolution contains many populations that belong to a story without continuing to its final pages. The archaeological remains give their legacy a practical dimension. Levallois-Cores show that useful forms were anticipated before the final strike. Stone carried from distant sources reveals movement across a known landscape. Gazelle bones preserve cutting and marrow extraction. Heated flint records fire and, by an accident of mineral physics, became the clock that established the site's age. These traces show planning, mobility, and learned skill, but they do not supply proof of art, formal burial, religion, or modern language. Jebel Irhoud is significant without being made more elaborate than its evidence allows. The scientific legacy also lies in method. The first skull entered research without a secure coordinate because mining had disrupted the shelter. Decades later, renewed excavation recovered Layer 7 and reunited anatomy with stratigraphy. Irhoud 10 was rebuilt from crushed fragments through microcomputed tomography, rather than presented as an untouched face. Irhoud 11 connected a robust adult jaw to the intact layer, while the recalculated age of the Irhoud 3 tooth supported the heated flint chronology. The argument became strong not because one specimen answered everything, but because independent evidence converged while its limitations remained visible. That history warns against dramatic certainty. Early researchers were not irrational to compare the skulls with Neanderthals. They worked with damaged context, a younger presumed age, and European technological categories. The interpretation changed when better excavation, dating, and three-dimensional comparison changed the evidence. Jebel Irhoud became a landmark through revision, showing that the human past advances when old names are tested rather than protected. The absence of symbolic objects does not place the population outside humanity, just as a modern-looking face does not make them identical to humans today. Archaeological behavior does not evolve as one package any more than anatomy does. Technologies can become sophisticated before durable ornaments appear. Social traditions can exist without leaving recognizable symbols. Language may have had deep precursors, yet no stone tool can preserve its grammar. The most accurate portrait is therefore one of capability surrounded by uncertainty. In 2026, the human history of Morocco extended still farther back with fossils from Thomas Quarry I in Casablanca, dated to around 773,000 years ago. The jaws, teeth, vertebrae, and limb remains belong to a much older population, often interpreted within Homo erectus in a broad sense, and displaying a mixture of primitive and more derived traits. They show that North Africa held important human populations hundreds of thousands of years before Jebel Irhoud. The new fossils do not create a direct ancestral chain. A gap of nearly 500,000 years separates the central dates of the two sites, and the intervening record remains sparse. The Casablanca population may lie somewhere near deeper branches from which later lineages emerged, but no fossil sequence demonstrates that its descendants became the people of Jebel Irhoud. The finding strengthens North Africa's importance while preserving the mystery of continuity. That mystery may become the lasting legacy of the Moroccan record. Jebel Irhoud no longer stands alone against an empty regional past, yet the population that gave rise to its familiar faces remains unidentified, somewhere among African groups living through repeated climatic change. The traits seen at the site were assembled, shared, and reshaped. Some came from older ancestors. Others may have emerged within networks that stretched across the continent. The fossils capture one moment in that movement, not its beginning or its end. What they leave behind is a different image of human origins. It is not a point on a map from which finished people spread outward. It is a wide field of populations connected unevenly over time, with anatomy and behavior developing in overlapping sequences. Jebel Irhoud matters because it catches that process while it is still visible in the bones. A face approaches the human form we know, but the skull behind it remains long and low. In that contrast, our lineage appears not as a completed design, but as an evolving population still becoming itself. The limestone shelter is quieter now. Much of it is gone, cut away by mining before anyone understood what the ridge contained. What remains is open to the sky, its ancient walls reduced to broken stone and exposed sediment. Beyond it, the Moroccan landscape stretches dry beneath the present sun, while the grasslands, seasonal water, and moving herds of the Middle Pleistocene survive only through scattered bones and environmental traces. The old fire is gone, yet its last heat remains measurable inside the flint. The people are gone, yet the curve of a cheekbone and the worn surface of a tooth preserve their place in time. Even absence has become part of the record. No genome, no burial, no complete body, no final answer. Inside the damaged shelter, the evidence is modest. A fragment of skull, a powerful jaw, teeth holding the rhythm of growth. A flint flake whose crystal structure remembers fire. None is complete, and none speaks alone. Together, they preserve the outline of at least 5 individuals whose lives cannot be joined into one family, one event, or one direct line leading to everyone alive today. They were not modern people placed unchanged in an ancient setting. Their skulls remained long and low, and the rounded internal form characteristic of later Homo sapiens had not yet fully emerged. But they were not primitive strangers standing outside our history. Their faces, jaws, teeth, movements, and technologies belonged within the early formation of the lineage that would eventually include us. Across Africa, other populations were changing as well. Some were separated by dry country. Others met when rivers returned and grasslands opened. Traits moved through those connections, disappeared in isolated branches, and reappeared in new combinations. No single cave, valley, or fossil holds the whole beginning. Jebel Irhoud offers something quieter than a birthplace. It offers a pause within a process fire glowing against limestone, stone tools lying near the remains of gazelle, people looking out across an open country that would later vanish. Their names, voices, and colours are gone. The exact paths of their descendants are unknown. Only the bones remain, preserving a strange familiarity. Beneath heavy brows and long cranial vaults, the faces turn toward a form we recognize. They wait at the threshold, neither copies of us nor figures entirely apart, while the light beyond the shelter falls across a humanity that is still, slowly, taking shape.